MIT engineers have built a robot smaller than a human thumb, lighter than a paperclip, and yet capable of leaping over obstacles like it owns the terrain. Ice, wet floors, uneven soil, nothing slows it down. 4 spring-loaded legs propel it skyward, 4 tiny wings stabilize it mid-air. It carries 10 times its weight with perfect balance. This isn't science fiction, it's the dawn of micro-robots that could change everything. 10-cent robot butler. A humanoid robot steps into homes with the precision of a master and the intuition of a human. It chops, stirs, and cooks meals while simultaneously cleaning every surface with flawless efficiency. Children are guided, pets cared for, and routines perfectly synchronized without a single command missed. Advanced AI lets it adapt to every household, predicting needs before they arise. Its dexterous limbs move with uncanny grace, while sensors ensure nothing is ever misplaced or broken. This isn't automation. It's an entirely new class of domestic intelligence. Showcased on global stages, the robot astonishes with versatility and lifelike interaction. Homes are no longer just living spaces. They are managed ecosystems, orchestrated silently by a machine that feels almost alive. Ferrofluid display. A dark magnetic liquid dances inside a clear tank, forming spikes, waves, and logos with hypnotic precision. Hidden electromagnets choreograph every movement, pulling the ferrofluid into living shapes that respond to sound, light, and timing. Each magnet acts independently, creating complex patterns that twist, ripple, and morph as if the liquid has a mind of its own. Custom shows, lasers, and colored LEDs amplify the spectacle, transforming science into mesmerizing art. Museums, tech installations, and events witness a fusion of physics and creativity unlike anything seen before. The ferrofluid is more than display, it is dynamic, responsive, and alive, turning raw magnetism into an interactive visual language. What was once static becomes kinetic, blurring the line between technology and performance in a breathtaking symphony of motion. Microfluidic cooling. Tiny channels, thinner than a millimeter, snake across circuits like veins, carrying coolant directly to the hottest spots. Heat doesn't just dissipate, it is controlled, directed, and removed with surgical precision. By mimicking blood vessels, microfluidic systems maximize surface contact, ensuring uniform cooling across AI chips and high-performance electronics. Laminar flow reduces resistance, while every droplet works to maintain optimal temperatures. Data centers, gaming rigs, and quantum labs gain unprecedented efficiency, consuming less power and producing less noise. Devices last longer, operate faster, and survive conditions that would destroy traditional systems. Engineers can now harness extreme performance without compromise. What was once a limiting factor, overheating, is now an opportunity. Heat becomes a tool, a resource, and a silent partner in the next generation of technological breakthroughs. Lab-grown meat. Meat grown from cells, no farms, no slaughter, just science. Petri dishes become steaks, burgers, and nuggets, cultivated with precision to mimic taste, texture, and nutrition. This is sustainability engineered. Drastically lower greenhouse gas emissions, minimal water use, and zero land required for livestock. AI monitors cell growth, optimizing conditions for efficiency and cost reduction. Companies are scaling production, aiming for competitive pricing with conventional meat, making ethical choices accessible to everyone. Food becomes clean, controlled, and customizable, shifting the way humanity consumes protein forever. From lab to plate, every bite is engineered, traceable, and environmentally responsible. What was once a novelty is now a blueprint for the future of food, scientific, ethical, and undeniably revolutionary. Microsoft underwater data centers. Beneath the ocean's surface, sealed server modules rest in silent cold water, using natural cooling to operate with unprecedented efficiency. Phase 2 deployed 12 racks, 117 feet deep off Scotland's Orkney Islands, running for years with almost zero failures. Stable temperatures, minimal human interference, and constant seawater flow create the perfect environment for data at scale. Engineers learned lessons that reshape future data centers, inspiring liquid immersion cooling and energy-efficient designs. It's not just storage, it's innovation in extreme environments, leveraging nature's power for tech sustainability. Data flows underwater quietly and reliably, powering modern life while reducing energy costs. What once required massive cooling infrastructure now thrives below the waves, transforming the boundaries of computing, efficiency, and engineering forever. ESA Solaris Space. Solar. In orbit, massive solar arrays float above Earth, soaking up sunlight uninterrupted by night or clouds. The ESA Solaris project captures this relentless energy and beams it wirelessly to the planet below. Gigawatts of clean power travel invisibly, complementing terrestrial renewables and accelerating the path to carbon neutrality by 2050. Robotic assembly and high-efficiency solar cells turn engineering marvels into operational reality. Each panel, each laser-guided transmission is precisely calculated to maximize output. Space-based solar power no longer belongs in science fiction. It's becoming a scalable solution for global energy demands. By 2025, feasibility tests aim to prove the concept, positioning Europe as a leader in sustainable space energy. Humanity's energy horizon expands, reaching from Earth's surface all the way into the stars. QAA-ist exoskeleton suit. A sleek carbon fiber suit moves toward a wheelchair, aligning perfectly, then clicks into place. In seconds, a paraplegic user rises, standing tall for the first time in years. High-torque actuators at hips, knees, and ankles propel every step naturally, even climbing stairs and navigating obstacles effortlessly. AI-driven balance control and vision sensors anticipate every movement, correcting instantly to maintain flawless gait. The suit operates hands-free, transforming independence into reality. Muscle memory is restored digitally, motion amplified mechanically, confidence rebuilt emotionally. Laboratories call it revolutionary. Users call it life-changing. The boundary between human limitation and robotic precision vanishes. What was once impossible, walking, standing, moving freely, is now a mechanical extension of the human body, blending engineering, AI, and sheer will into seamless motion. Insta360 8K drone. A drone smaller than a backpack captures the world in 8K. Top and bottom lenses stitching seamless 360-degree footage. Flow state stabilization keeps every shot silky smooth, even at speed. Vision goggles put you in the cockpit, head tracking your view across 7 kilometers. Grip controllers and intuitive gestures let you fly like instinct, pointing, turning, and soaring without limits. Obstacle avoidance reacts instantly. Return to home ensures safety, and payload detection keeps operations precise. Modular design extends flights to 29 minutes, capturing epic cinematic sequences effortlessly. Creators now film immersive worlds once impossible to reach, every angle accessible, every moment perfect. The sky is no longer a boundary, it is a playground, and the Insta360 turns imagination into fully realized, breathtaking reality. Thermodynamic computing. Imagine a computer that doesn't think in electrons, but in heat, motion, and energy itself. Thermodynamic computing harnesses the chaos of physics, letting thermal noise and entropy guide solutions to complex problems. Instead of traditional silicon circuits, physical systems settle naturally into their lowest energy state, encoding answers effortlessly. Algorithms work with randomness, not against it, finding optimal solutions faster and more efficiently than anything digital logic can achieve. Labs are now creating hardware that literally computes with heat flows, turning wasted energy into raw intelligence. AI optimization, machine learning, and massive calculations are being rewritten, achieving energy savings hundreds of times greater than conventional methods. This isn't the future, it's happening now, and it could change how every computer on the planet thinks. Helion fusion reactor. Helion Energy is rewriting the rules of power with a compact fusion reactor that fits in a lab but promises energy on a massive scale. Inside, plasma made of helium-3 and deuterium is compressed to over 100 million degrees Celsius, hotter than the core of the sun. Magnetic fields twist and squeeze the plasma, triggering a neutronic fusion that produces electricity directly, bypassing turbines entirely. Every pulse is calculated, optimized, and controlled with precision software, creating a constant flow of energy from pure reactions. Their 7th-generation prototype is pushing toward net electricity output by 2025, while a commercial plant in Washington aims to power tech giants' data centers. Fusion that was once decades away is arriving, clean, efficient, and unstoppable. Kia Concept PV5 High Roof. The Kia Concept PV5 redefines cargo versatility with 5.1 cubic meters of space, easily fitting 2 Euro pallets. A sinking passenger seat and sliding partition door create a walk-through configuration, granting seamless access to every corner of the cabin. Low step heights and smart storage solutions make loading effortless. Advanced connectivity and driver-focused design turn functionality into intelligence, allowing real-time cargo monitoring and system integration. Every detail from roof consoles to cabin ergonomics is engineered for efficiency and comfort. Whether transporting goods or optimizing urban deliveries, the PV5 balances utility and innovation flawlessly. It's not just a vehicle, it's a mobile solution designed for the demands of modern logistics, turning everyday transport into a sophisticated, streamlined, and powerful operation.